All right, everybody. So we are going to be going over the season's exam, and we're going to start with number one. So number one says the table below shows the duration of insolation, right, which is the hours of daylight, measured by four observers, W, X, Y, and Z, at four different Earth's latitudes on both March 21st and June 21st. There were all clear skies at four latitudes on both days. Which observer was located at the equator? Now, what's very interesting is we should already know something about what's so special about the amount of daylight hours and the equator. The special thing about it is that when you're on the equator, every single day out of the year, you get 12 hours of daylight every day. Every day of the year. So whether it's March 21st, whether it's June 21st, whether it's October 21st, whether it's January, it doesn't matter what day it is, you will always have 12 hours of daylight every day of the year. And so the option that's going to show me that is observer X, because during March 21st and June 21st, I see that they're both 12 hours of daylight, which is choice 3. All right, number 2. Number 2 says the diagram below represents the orbital position on Earth on October 21st. And the question says, which northern hemisphere, that's a key thing, which northern hemisphere season is occurring where Earth reaches position X, right? So if October 21st is here, that means that technically right now it's fall, okay? And we know that to complete the entire cycle is going to take one entire year. So because I know this, if it's fall right here, we just traveled half the cycle, right? Half the cycle. So if we traveled half the cycle, that means we're moving half of the year. How many months is half of the year? 6 months. All right. So I need to think to myself, at position X is going to be 6 months from now. So if I start at October, right, then let's see 6 months from now. So first month, November, second month, December, third month, January, fourth month, February, fifth month, March, sixth month, April. And so because I traveled half of the year, because I'm moving half of the cycle, right? 6 months after October is April. And what season is April in? It is in spring. Choice B. All right, number 3. Number 3 says, during how many days of a calendar year is the sun directly overhead at noon in New Jersey? All right. So they're asking for, if you're located in New Jersey, how many days of the year will the sun be directly over your head at 12 p.m., right? At solar noon. All right. So this is what we need to know. There is a condition that takes place that lets us know which areas of the world will the sun be directly over your head. Because the reality is, not everywhere in the world will have that opportunity, unfortunately. I know it's sad. So, what's the rule? The rule is if you're located anywhere between the Tropic of Capricorn, and you're located somewhere, anywhere, and including the Tropic of Cancer. So if you're located anywhere in this area at some point in time during the year, the sun will be directly over your head at solar noon. Now, why is this important? Where's New Jersey? Well, I know New Jersey is definitely next to New York, right? And if I'm not mistaken, maybe I should zoom. Well, I need zoom. But New Jersey, New York, right? If America is right here, I know for a fact, that Florida is above that New Jersey is above Florida. So New Jersey is probably somewhere around this area, right? Because I know for a fact it's definitely above Florida. So you got to ask yourself, if this is New Jersey, is New Jersey located in this boundary area right here? It is not. So because New Jersey is not anywhere here, it's not anywhere in this region, in between these two latitudes, because New Jersey is not here and it's outside those boundary lines, that lets me know New Jersey will never have the sun directly overhead. And so because of that, the correct answer is going to be choice A, 0 days. Simply because it's outside of 23.5 degrees north all the way to 23.5 degrees south. If you're not anywhere on these latitudes or in between, then therefore the sun will not be directly over your head at noon. All right? So New York follows that principle as well too. You will get 0 days of the sun being directly overhead at noon as well. All right, number 4. Number 4 says, which diagram best represents the regions of Earth in sunlight on June 21st and December 21st? NP indicates the North Pole and the shading represents Earth's night side. Diagrams are not drawn to scale. All right. So we know that June 21st is the summer solstice. We definitely know that. And December 21st is what, everybody? The winter solstice. So here's what I do know. During the summer solstice, the North Pole has to be tilted towards the North Pole has to be tilted towards the sun. All right, during the summer solstice. That's what I do know. All right, that's the first fact. The second fact is that the North Pole has to be tilted away from the sun during the winter solstice. That's the other fact that I know. All right. Just by me looking, it can't be A because at June 21st, the North Pole is tilting away from the sun, and that is incorrect. Right? And December 21st is saying that the North Pole is tilting towards the sun. That's incorrect. All right. It can't be B because the North Pole has to be tilting towards the sun on June 21st. And the right here it's showing that the North Pole is not necessarily tilted towards or away, so it can't be B. However, when I'm scrolling and I look at C, all right, when I look at C, let's see. One thing I notice, I see in June 21st, the North Pole is tilting towards the sun. The North Pole is tilting towards the sun, right? So that is correct. And during the winter solstice, the North Pole has to tilt away from the sun. That's why the correct answer is choice C, right? When the North Pole is tilting towards the sun, the North Pole is getting more sunlight. Hey, it's the summer solstice. When the North Pole is tilting away from the sun, hey, the North Pole is not getting any sunlight. It's the winter solstice. Choice C is the correct answer. All right, number 5. So number 5 shows the duration of insolation at different latitudes for 3 different days during the year. I do believe if you look at one of my other videos, it definitely has this question that we're going to break down, but I'm going to just quickly break it down. It says, which dates are represented most correctly by day 1, day 2, and day 3? Here's the main thing that I see. All right, I'm looking at day 2. At day 2, every single latitude is 12 hours. That lets me know automatically that it's either going to be the fall equinox or the spring equinox, which means it either has to be, right, September 21st or 22nd, doesn't matter, or March 21st, sorry, or 22nd. All right. And when I look, I can automatically cross out B, right? Because day 2 should have a September date, September 21st or 22nd, or a March date. So B cannot be the answer so far. All right. Let's keep it going. Now, what's interesting, let me just erase. Oops, sorry. All right. Now, what's interesting also about this is I'm looking that all of these latitudes are in the north, right? Except for the equator. All the latitudes are above the equator in the north side. That lets me know during the summer solstice, it makes sense that the north part of the world is going to get more sunlight. All right, keep that in mind. During the summer solstice, the north part of the world is going to get more part of the world gets more sunlight. All right, we're exposed to the sun a lot more during the summer solstice. So which day is the north part of the world, right, the northern latitudes, receiving more and more sunlight? I'm definitely looking, and it seems to be day 1, right? So day 1 definitely has to be the summer solstice. All right. And as we said, day 2 definitely has to be the equinox dates, any of the equinox dates. So when I look, the first day has to be the summer solstice. It can't be D because the first day is winter. It can't be A. And so the correct answer is C. All right. And honestly, that also makes sense because during day 3, look at all the daylight hours for all of them. Now it's less daylight hours, right? And as we in New York, we know during the winter we get less daylight hours. So it's clear that day 3 shows the winter solstice. So your correct answer is choice C. Number 6. Number 6 says, which graph best shows the length of a shadow cast from sunrise to sunset by a flagpole in New York State? Here's what we know. When the sun's altitude is high, the shadow is small. The shadow is small. When the sun's altitude is high, the shadow is small. When the sun's altitude is low, the shadow is very large. All right, when the sun's altitude is low, the shadow, excuse my handwriting, is long, right? shadow's long. So there are 2 times of the day where the sun's altitude is very low. 2 times of the day where the sun's altitude is very low. That is sunrise and sunset. Sunrise and sunset. And here's what I need to know. When we said it right here, when the sun's altitude is low, your shadow has to be long. It has to be large. It has to be big. Which option shows me that during sunrise and sunset, my length of the shadow is the biggest? Right here, choice 4. During sunrise, my shadow is very long. During sunset, my shadow is very long. And then if we take a look, the sun's altitude, when it's high, your shadow's small. When you're at noon, the sun's altitude is very high, and the length of your shadow is very small. That's why the correct answer is choice D.